Alright guys, welcome to the last part of Exam 1 review. We're going to be going over Chapter 3 Problem 3.108. Feel free to pause the video so you can look at the question, read it ahead of time, get your given and find solution as always, and we'll go ahead and get right onto it. Problem states that a 6 by 12 inch plate is subjected to 4 loads as shown. Find the resultant of the 4 loads and the 2 points at which the line of action of the resultant intersects the edge of the plate. Now I know reading that you're like, wow, all I got from that was resultant. I don't know what the other two parts of that question mean. So basically the question asks is find the resultant of all those forces, those 4 forces. And then the next part asks you is where that resultant's going to be placed in the x and y direction. So with that being said, we'll go ahead and start right off on it. So let's find our force resultant. Force resultant is going to be, when you look at these forces, the larger of the forces that are acting at the top left-hand portion between A and B, you have 40 pounds going to the left and 50 pounds going to the up and to the right. If you add those two together, you get a larger sum of forces rather than from point C and point E. Therefore, that's most likely where our resultant's going to be coming from. That being said, we can say that negative 40 pounds in the I direction plus 20 pounds in the J direction, because we're looking at point C as our pivoting point. That pretty much is what you're kind of looking at. Point C is going to be like where the moment's going to occur, just because when you look at point C, if you pin it, point C is where most of your other 3 remaining forces are going to cause a moment rather than some of the others. You can do it from any other point that you want to, but for this sake, since the resultant's probably happening on the top left-hand portion, I'm going to use part C, or point C, as my pivoting point. So with that being said, our resultant for this one comes out to 44.72 pounds. Now we need to find our moment about C. Our moment about C is going to be R of BC cross our force B, because that's the closest thing that's causing a moment at point C, at the line of action that we're looking into. That being said, we have a negative 6 inches I times a 50-pound force cosine, and I'm pulling my 50 out because it is a common factor. 45 degrees the cosine plus sine of 45 degrees. Now my picture's not really drawn to scale, but if you actually look at the picture from the problem stated, it is put at a perfect 45-degree angle. That is where I am getting my degrees from. And this is in the J direction. Solving that, our moment about C comes out to negative 212.13 pound inches in the K direction. Now the problem didn't specifically ask for us to find the moment, but we're going to need the moment to find our X and Y directions. So I will label that as part A. Part B, we need to find our X direction in inches. To find that, we're going to take our moment about C is equal to a negative X direction, because we're looking at point C, times our 20 pounds in the J. We know our moment, 212.13 pound inches. We don't know our X, and we know the 20. So solving for X, we get 10.61 inches. For our Y, we're going to do the exact same thing. Moment about C is equal to a negative Y direction, because we have to go down from point C. If we go up, we're off the plate. Same thing for the X direction. If we would have went to the right, we would have been off the plate. Therefore, all of the math will not work. So we're going back into the plate, which is going to be a negative Y direction. This is going to be in the J. across negative 40 pounds in the eye, because that is what's causing that part of the moment. Again, we know our moment, 213.13 pounds, inches, is equal to a negative y that we don't know. It's not an I, wait, it's j, times a negative 40 pounds in the I direction. Solving for y, we come out to 5.30 inches. Feel free to pause the video at any point of time to catch up and kind of figure out where I'm getting some of the forces, angles, and everything. This problem right here is a very, very good problem to study for this exam. He will have something very similar to this on the exam, so watch out for it. Other than that, that completes our exam review for exam 1 for chapters 2 and 3. If you have any questions, feel free to email me or Jackson, and that will be it. Have a